TCCS minimum performance criteria, assuring fast, reliable, and deterministic execution of critical control and protection tasks. System performance philosophy. The Turbo Compressor Control System, TCCS, is designed to meet stringent real-time performance benchmarks, ensuring that all control loops, protection functions, operator interfaces, and diagnostic systems operate with high speed and reliability, even under worst-case plant conditions. This ensures personnel safety, machine protection, and continuous availability without lag, data loss, or delay-induced instability. The system's architecture, including controllers, networks, and HMIs, is engineered to execute and update logic within clearly defined time constraints, even when all subsystems are active concurrently. Performance criteria by subsystem. Master pressure and load sharing controllers. Control loops for master pressure and intertrain load sharing must execute read, compute, write cycles within 100 milliseconds. Maintain tight response under varying load, speed, and surge margin conditions. Anti-surge controllers. Surge protection loops require total execution time, input to output of 50 milliseconds or less, high responsiveness to flow disturbances and near surge conditions, deterministic behavior under multiple active surge loops. Sequence and interlock logic. Safety interlocks, startup, and shutdown sequences must complete total logic scans in less than 100 milliseconds, maintain full performance even when all auxiliary systems, valve interlocks, and permissives are active simultaneously. Human-machine interface, HMI. Operator visibility and interaction must be immediate and accurate. Graphic page draw time, maximum 2 seconds from page request to full display. Dynamic value update time. All real-time values must refresh within 1 second. Data logging capacity. HMI should store a minimum of 30 days of historical data without exceeding 50% of hard disk capacity. Sequence of events, SOE recording. Critical for diagnostics and root cause analysis, alarm and event discrimination with a resolution of 100 milliseconds, even during bursts of up to 100 events per second. Full synchronization with DCS clock for unified plant event logs. Vibration monitoring system. Real-time data from vibration probes and proximity sensors must be updated at the TCCS within 2.5 seconds maximum. Support simultaneous viewing, alarming, and logging across all active channels. Communications and data links. Network utilization guidelines ensure smooth operation. Deterministic protocols, e.g. Modbus TCP, OPC UA redundant, not to exceed 50% network bandwidth usage. Non-deterministic protocols, e.g. Ethernet peer links, capped at 30% usage. Any loss of communication shall have zero impact on the compressor's real-time control functions. # operational assurance under load. The system is tested and guaranteed to perform all critical functions simultaneously, including running surge control, load sharing, and startup sequencing. Logging alarms and events in real time, displaying operator graphics and HMI trends, communicating with external systems like DCS, ESD, and CMS. Performance is benchmarked not under ideal lab conditions, but under full system load, replicating real-world operational stress. This ensures that the TCCS remains resilient, fast, and fail-safe, even in high-demand or faulted scenarios. Human-machine interface, HMI, real-time visualization, diagnostics, and control interface for operators and maintenance personnel. The human-machine interface, HMI, embedded in the Turbo Compressor Control System, TCCS, is the primary window into compressor and turbine operations. Designed with intuitive navigation, real-time updates, and layered access security, the HMI allows operators to monitor, interact with, and diagnose the turbo compressor package efficiently and safely. It provides interactive graphical displays, alarm handling, trend analysis, and report generation, while ensuring no control actions are dependent on the HMI, guaranteeing uninterrupted compressor functionality even if the HMI fails. HMI core functions. Real-time dynamic graphics. Displays live process variables, controller statuses, and machine states. Includes animation of valve positions, set point indicators, and alarm symbols. Alarm and event enunciation. Categorizes alarms, process, hardware, communication with color codes and priority levels. Supports first-out enunciation and detailed SOE, sequence of events logging with 100 milliseconds resolution. Trending and historical data. Live and historical trends are available for all analog variables. Operators can adjust time ranges, zoom in, out, and scroll through time-based events. Diagnostics and health monitoring. Presents real-time hardware and I/O diagnostics, including signal integrity, module status, and communication health. Self-test results and internal fault flags are displayed in clear, actionable formats. Maintenance tools. Enables manual device actuation, signal simulation, and configuration backup in maintenance mode. Displays sensor calibration values and deviation checks for maintenance verification. Report generation allows creation of custom or scheduled reports such as daily operation summaries, maintenance metrics, alarm event lists, compressor efficiency, and performance logs. Reports are stored in PDF or CSV formats and can include embedded trend plots. Integrated help system. Context-sensitive help provides on-screen explanations of symbols, terms, alarms, and controls. Link PDF manuals are accessible from within the HMI. HMI hardware platform, industrial PC-based architecture, housed within each unit control panel, UCP, built with rugged hardware capable of continuous operation under harsh conditions. Operating system and software, based on Microsoft Windows 2000 or XP, configurable to modern platforms. Uses industry-proven SCADA or HMI software with support for OPC and Modbus data interfaces. Resilience and independence. Failure of the HMI does not impact control functions. All turbine and compressor control logic remains active and independently executed by the core TCCS processors. HMI graphical display package. Standard display set includes overview screen for each compressor train, turbine performance map, and live speed power curves. Compressor stage maps with surge line and real-time operating points, lube oil and seal gas systems displays, anti-surge controller and valve displays, load sharing and performance controller interface, vibration and temperature trend panels, alarm summary, first out alarms, and history, system diagnostics and test reports, manual command and maintenance access pages, help and document access area. All displays are configurable and new graphic pages can be added post-commissioning. Security and access control, role-based access levels. Access rights are defined by role, operator, supervisor, technician, engineer. Tasks such as tuning, alarm inhibit, and configuration changes are restricted accordingly. Audit trail and action logging. All user interactions, including set point changes and alarm acknowledgements, are timestamped and logged. Printing and data storage, local printer, used on demand for selected reports such as daily logs or maintenance summaries. Historical archive, minimum of 30 days worth of operational and alarm data stored locally with buffer to prevent disk overfill, 50% free capacity maintained. HMI failure contingency. In the event of HMI failure, compressor operation continues uninterrupted. All critical data remains available at the DCS via OPC communication. Maintenance personnel can restore functionality using spare licensed software and backup configuration files. The HMI thus acts as a powerful tool for monitoring, managing, and maintaining the turbo compressor system without introducing risk to real-time control or safety. Report generation, automated and on-demand reporting for operational transparency, maintenance planning, and performance analysis. Reporting capabilities within the TCCS HMI. The Turbo Compressor Control System TCS includes robust report generation functionality embedded in the human-machine interface HMI, enabling both operators and maintenance teams to access detailed, structured, and historical insights into the performance, status, and health of the turbo compressor systems. Reports are generated either on demand by authorized personnel or automatically on a scheduled basis and are saved in accessible formats for review, printing, or archival. General reporting features. Configurable report scheduling. Reports can be set to generate daily, weekly, or monthly, automatically saved to disk with time-stamped file names. Manual trigger option. Operators and engineers can generate specific reports manually at any time to capture event snapshots or perform quick diagnostics. Free format layouts. Reports are presented in a spreadsheet-style format, allowing inclusion of tabulated values, graphical elements such as charts or trends, statistical summaries, min, max, average, embedded process graphics, optional. Reports can include static images or plots from active display screens, e.g., compressor maps, trend overlays, alarm timelines. File storage and recall. All reports remain locally stored after generation. Operators can recall past reports directly from the HMI, reprint or export them without regeneration. Software tools for customization. The system includes licensed tools to allow trained personnel to add new report templates, modify report content, e.g. add parameters, adjust formatting and headers. Data sources for reports. All data included in reports is pulled from live process values, historical trends, alarm event logs, runtime counters, and diagnostic flags. Predefined standard reports. Turbo Compressor Operation Report Daily includes timestamp and shift operator ID, total runtime, cumulative and daily, fuel gas type and hours operated on sour gas, if applicable, number of starts, attempted and successful, hourly/daily averages of suction and discharge pressures, flow rates, key temperatures, bearing, exhaust, ambient, turbine speed and power, compressor efficiency calculations, totalized flow throughput. Turbo Compressor Maintenance Report includes total runtime since new and since last overhaul, peak temperatures and vibration levels, number of protection alarms triggered, remaining time to overhaul, TBOH, based on OEM criteria, startup failure logs, if any, summary of alarm event list over the defined reporting period, system diagnostic test results, operator intervention log, manual trips, mode changes, overrides. Report access and printing. Local print function. Operators can print selected reports via the integrated color printer, on demand or after automatic generation. Remote access via DCS or maintenance systems. Reports stored in the TCCS can be accessed through network paths or exported via USB or shared drives, configurable during commissioning. Archival policy. Reports are stored for a configurable retention period, e.g. 30 days or 90 days, after which they are automatically archived or deleted to manage disk usage. Use cases and benefits. Operational oversight. Daily reports provide supervisors with a snapshot of system performance and availability. Maintenance planning. Maintenance teams use runtime and alarm reports to prioritize inspections and parts replacement. Incident review. In the event of a shutdown or alarm trip, reports help reconstruct system behavior for root cause analysis. Audit and compliance. Logged reports support regulatory compliance and internal audits, documenting safe and consistent operation. With its flexible reporting architecture, the TCCS empowers users with clear, data-rich documentation that bridges real-time control with long-term performance and maintenance intelligence. Programming, configuration, and software. Structured engineering framework for safe, modular, and maintainable control logic. Software philosophy and standards. The Turbo Compressor Control System TCCS is engineered using a structured, standards-based software development approach that emphasizes reliability, clarity, and long-term maintainability. All programming and configuration activities follow IEC 6131 standards with an emphasis on modular design, documentation, and change traceability. The goal is to ensure that every software component, from control logic to HMI configuration, is robust, verifiable, and easy to update during future expansions or troubleshooting events. General software requirements. Design methodology. Software is developed using a modular block-based approach with reusable templates and function blocks for compressor sequencing, anti-surge control, load sharing, auxiliary interlocks, alarm and diagnostic handling. Code characteristics. All software is efficient in execution, real-time capable, clearly structured and navigable, self-documented with inline comments, easy to troubleshoot using variable watch and live debug modes, designed with error trapping and diagnostic escalation. Design assurance. Programming tools must support offline simulation and testing, version control and backup, validation of changes prior to download, controlled deployment to live systems with no interruption of running machinery. Quality framework. Vendors are expected to demonstrate compliance with ISO 9000 quality management standards for software lifecycle processes. The company may audit software development workflows at any stage. Application software development. The vendor develops and delivers fully functional software covering startup and shutdown sequences, protection and interlocks, controller algorithms, e.g. PID surge performance, HMI navigation and displays, communication drivers to DCS, ESD, MCC, and CMS. Documentation deliverables. The vendor provides detailed logic diagrams and tag references, configuration files in native and export formats, I/O point-to-function mapping, controller configuration reports, software architecture overviews. Code transparency. All programming must be human-readable, even for non-proprietary systems, ensuring maintainability by the owner post-commissioning. Software interfaces and data sharing. External system integration. The TCCS interfaces with Distributed Control System DCS via OPC Modbus TCP, Emergency Shutdown System ESD via hardwired I/O, Motor Control Centers MCC via relay logic and status inputs, Condition Monitoring System CMS via Ethernet or serial links. Interface mapping. The vendor collaborates with other package vendors and the owner to define memory blocks and communication structures, establish signal ownership, timing, and responsibility, coordinate time synchronization and SOE alignment, configuration and maintenance tools. Toolkits provided. The vendor supplies software for online configuration and parameter tuning, offline simulation and debugging, HMI editing and trend group creation, loop tuning and auto calibration, diagnostic testing and data export. Licensing. At least one additional set of licensed software tools must be provided to the owner for standalone use. Support or update contracts must cover a minimum of 12 months from handover. Supported operations via configuration tools. Add, delete I/O points, modify logic or sequencing routines, tune PID and surge controller gains, configure new reports and alarms, adjust HMI layouts and navigation, update communication parameters, perform backups and restore functions, execute diagnostic tests and module health checks. Tagging and naming convention. Standardized tagging. All software elements, variables, alarms, controllers must adhere to the project-specific instrument and electrical tagging specification. Tag allocation. The owner will assign specific tag ranges per system or train. Dual tagging or parallel naming systems are not permitted. Software security and backup. Access protection. Software tools include role-based access control to prevent unauthorized edits or downloads. Backup policy. The vendor must retain a full copy of the final application software with hard copy of logic diagrams and reports, electronic files and license keys, documentation for reinstallation and recovery procedures. Startup and reboot sequence. The vendor must define where each logic block resides, volatile versus non-volatile memory, how the system restores from power loss, time to full functional recovery after reboot to be verified during FAT. Error handling and validation. Input validation. All operator entries, whether from HMI or DCS, must be validated. Out of range or invalid values are rejected. Clear feedback messages are provided for corrections. Safety threshold enforcement. No operator or system command may override preset trip or protection limits without specific engineering authorization. By enforcing this disciplined and transparent approach to software development and configuration, the TCCS ensures a reliable, traceable, and upgradable control environment that is aligned with long-term operational success and maintainability. Fire and gas detection and suppression, integrated safety layer for early hazard detection and automatic response within turbine enclosures. Safety system overview. The Turbo Compressor Control System TCCS includes a fully integrated fire and gas FNG detection and suppression subsystem to protect the turbine enclosure and adjacent process areas from combustion-related hazards, designed in accordance with international standards such as NFPA PA72, NFPA 7750, and NFPA 12 height. This system provides early detection, local and remote annunciation, and automatic suppression activation to mitigate fire and gas incidents. All detection devices are hardwired to the skid edge junction boxes and interface with the external platform F&G system, which executes final shutdown actions and suppression logic. The TCCS acts as the interface and control enabler for detection, signaling, and interlock readiness. Functional scope of F&G integration: hazard detection and alarm generation. Gas detectors, flame detectors, and heat sensors are strategically placed to detect hazardous conditions. Each detector type is configured for 2 out of N voting logic, except where single voting is required for rapid response. Signal exchange with F&G system. All inputs and outputs between the turbine skid and F&G system are hardwired for reliability and fail-safe execution. The TCCS transmits readiness signals and receives hazard status for coordination of shutdown and suppression. Suppression system control and monitoring. The TCCS monitors the health, readiness, and actuation status of water mist or CO2 suppression systems. Visual and audible alerts are generated locally on the Unit Control Panel, UCP, HMI, and remotely on the Distributed Control System, DCS. Shutdown coordination. On fire or gas detection, the TCCS executes a controlled turbine shutdown, coordinates with the Emergency Shutdown System, ESD, activates permissives and sequencing for safe depressurization and blowdown, if configured. Alarm handling and enunciation. Alarm states such as fire detected, gas present, suppression discharged, or manual release activated are enunciated and logged on the HMI and DCS with full SOE resolution. TASH equipment scope provided by vendor. Fire and gas detectors. Gas detectors IR type located at turbine enclosure inlet-outlet vents and combustion air intakes. Flame detectors, UV IR or triple IR, mounted to cover critical flame zones inside the enclosure. Heat detectors set 30 degrees Celsius above normal ambient for fast fire indication without false trips. Suppression system. Either water mist, as per NFPA 750, or CO2, as per NFPA 12 system. Includes pressurized bottles, piping, actuation panels, relief valves, and check valves. System rated to operate for 10 minutes minimum after turbine shutdown to ensure full hazard neutralization. Redundant storage with 200% capacity split into primary and reserve cylinders. Control and monitoring panel that mounted outside the turbine enclosure on the skid includes indicators for system ready, locked out, bottle pressure low-high, manual activation triggered, system discharged. Manual actuation stations located outside and inside the turbine enclosure doors enable local personnel to manually release suppression agent. Override capabilities to disarm system during maintenance are protected by access control. Warning and safety indicators. Flashing lights inside and outside enclosure to indicate gas release or system activation. Audible alarms to alert personnel prior to suppression discharge. Tamper-proof tags warning personnel of automatic suppression hazards. Functional safety and integration highlights. Hardwired logic over serial communication. All critical F&G actions, such as hazard input detection, suppression release commands, and shutdown trips, are executed via hardwired logic, ensuring rapid and fail-safe response. Redundancy and reliability. Sensors are installed in redundant configuration, and control paths include primary and backup activation channels to meet high safety integrity level SIL requirements. Startup and health checks. During system boot up or compressor readiness checks, the TCCS verifies detector self-check status, suppression bottle pressures, line integrity and signal path continuity, alarm silencing and test functionalities, integration with TCCS and ESD. Upon F&G alarm activation, the following are coordinated: compressor shutdown and trip logic, emergency blowdown signal if configured, inhibition of auto restart until hazard is cleared and acknowledged. Maintenance, calibration, and testing. Vendor-provided test equipment. Includes calibration kits, simulators, and gas sources for detector testing. System simulation mode allows safe testing of detection and suppression logic without actual discharge. Cause and effect diagrams. Delivered by the vendor to define logic paths and interface actions between detection inputs, shutdowns, and suppression release. Purchaser approvals and layouts. Final detector locations, voting logic, and suppression zone boundaries are subject to purchaser review and approval before fabrication. Summary. This fully integrated fire and gas detection and suppression arrangement provides a comprehensive, multi-layered safety net within the TCCS framework. By combining fast hazard recognition, automatic compressor protection, and reliable suppression response, it ensures that personnel, equipment, and process continuity are safeguarded at all times. Field instrumentation, precision sensing and signal conditioning for reliable compressor control and protection. Overview. The field instrumentation network of the Turbo Compressor Control System TCCS serves as the sensory foundation for real-time control, protection, diagnostics, and performance monitoring. Every sensor, transmitter, and field-mounted device is selected, installed, and integrated in line with stringent project specifications and industry standards to ensure accuracy, reliability, and maintainability in demanding process environments. All field instruments associated with the TCCS are fully aligned with the control philosophy, piping and instrumentation diagrams, P&IDs, and the general specification for instrumentation and control for package equipment. Scope of supply and integration, complete field instrument package. The TCCS vendor is responsible for supplying all instruments located on the compressor skid as defined in the project P&IDs and equipment data sheets. Wiring and termination. All instruments are factory wired to skid edge mounted junction boxes. These junction boxes interface with unit control panels, UCPs, external fire and gas F&G systems, other auxiliary panels as needed. Instrumentation functionality. Devices are used for a wide range of functions including surge control sensing, flow, pressure, temperature, vibration and thrust monitoring, seal gas system feedback, fuel and lube oil system control, auxiliary system diagnostics, safety shutdown inputs and permissives, instrumentation requirements and specifications. Instrument type and quality. All instruments must be industrial grade, high accuracy, and long life, compatible with the process conditions, temperature, pressure, gas composition, resistant to corrosion and vibration, certified for hazardous area use where applicable. Preferred signal types, analog signals, 4 to 20 milliamps loop-powered signals for pressure, flow, and temperature. Digital signals, dry contacts or NMR for switches and discrete status. HART protocol support, encouraged for smart diagnostics, calibration, and commissioning. Location and accessibility. Field transmitters and switches are mounted outside hot compartments where feasible. Devices are positioned for easy access during operation and maintenance. Vibration probes and thermocouples are installed on rotating and static parts per OEM recommendations. Instrumentation for performance testing. The vendor shall provide dedicated taps and fittings to support live performance testing, additional instrumentation to capture turbine output, compressor efficiency, and stage-wise pressure ratios. Anti-surge valve instrumentation. The surge control valves must be equipped with high-speed positioners, position feedback transmitters, integrated diagnostics. These valves must meet tight control and fast response requirements as they serve both surge protection and process recycle functions. Skid edge interface and layout. All signal wiring from field devices is routed to explosion-proof or weatherproof junction boxes at the skid edge. These boxes are clearly labeled and include terminal strips for quick connection to site cabling. Final termination to UCPs and external systems is completed by others based on standard interface definitions. Instrument wiring is laid out to minimize electrical noise and crosstalk, maintain segregation between analog, digital, and high-power circuits, support loop checks and commissioning activities without disruption. Commissioning and testing provisions. Loop testing and verification. All instrumentation loops are tested for continuity, range calibration, response time, alarm and trip functionality. Installation quality. Tubing and mounting hardware for pressure, temperature, and flow instruments must meet leak-free operation under full load, ease of removal and reinstallation, clear labeling, and tag plate visibility. Diagnostic support. Smart instruments support. Remote diagnostics from the HMI, auto-identification and configuration, fault alerts in case of signal drift, loss, or calibration deviation. Special considerations. Instrument redundancy for critical measurements such as fuel gas pressure, lube oil pressure, seal gas flow pressure. Redundant dual or triple transmitters are installed, enabling signal voting and fail-safe logic. Environmental compliance. All instruments exposed to turbine enclosure or external atmosphere are rated for extended temperature and humidity, compliant with ingress protection standards, e.g. IP65 or higher, resistant to trace corrosive gases such as H2S or chlorine. Summary. The field instrumentation layer of the TCCS ensures that control algorithms are supplied with accurate, real-time process data, while protection logic is backed by high-integrity sensing infrastructure. By combining rugged design, digital readiness, and seamless integration with control panels and external systems, the TCCS instrumentation package establishes a solid foundation for safety, performance, and reliability.